At 24 minutes past 5 on Thursday afternoon, the United States Geological Survey did something it almost never does. It opened the official earthquake catalogue of the United States, the same catalogue that emergency managers and nuclear power plant operators watch in real time, and it typed 2 words into the event description field that were not the word earthquake: sonic boom. 6 kilometers north-northeast of St. Andrews, South Carolina, magnitude 0.0, depth 0 kilometers. The catalogue entry exists in the public record right now. You can pull it up on the agency's website, and in the 12 hours after the entry was published, NASA went on the record to confirm it was not a meteor. Shaw Air Force Base went on the record to confirm it was not one of their F-16s, and a third federal agency, 15 miles southeast of the catalogue location, has not gone on the record at all. So what produced an atmospheric pressure event strong enough to be felt across 100 miles of the southeastern United States by hundreds of thousands of people, that the United States government is publicly confirming was not an earthquake, was not a meteor, and was not a Shaw aircraft? Before we go any further, if you enjoy what we do here at The Outer Layer, hit like and subscribe so you don't miss any of our daily reads. Also, drop a comment and tell me where you're watching from. Let's get into it. Part 1. The minute the air hit. At 24 minutes and 30 seconds past 5 in the afternoon, Eastern Daylight Time on Thursday the 28th of May 2026, the air over central South Carolina did something that nobody who felt it could explain. A pressure wave moved across the Midlands. It rolled through Columbia and Casey and Lexington. It rattled windows in Newbury and Orangeburg. It pushed itself across Sumter and Florence and out toward the coast. It travelled north into the Charlotte metropolitan area in southern North Carolina. It travelled west into Greenville and Anderson. Doorbell cameras across more than 100 linear miles caught the audio. Phones lit up. Hundreds of thousands of people in the southeastern United States felt something pass through them that they could not identify, and the first instinct, as it almost always is when the ground or the air does something it should not be doing, was that an earthquake had just happened. The first guess was wrong. The second guess was wrong. The third guess was, by Friday morning, also wrong. And what the United States Geological Survey did with that minute is the reason this story exists. What the agency did was extraordinary, and to understand why it was extraordinary, you have to understand what the agency normally does. The United States Geological Survey runs the official earthquake catalogue of the United States. That catalogue is one of the most consequential scientific data feeds in the world. It is read by emergency managers, by structural engineers, by insurance carriers, by the Federal Emergency Management Agency, by nuclear power plant operators, by aviation authorities. When the catalogue shows an event, decisions are made within minutes that affect lives, property, and infrastructure across a continent. The agency does not casually add entries to that catalogue. The catalogue is for earthquakes. The catalogue is for events that happened in the ground. And on the afternoon of May 28th, the agency added an entry to the catalogue that was not an earthquake. The entry had an identifier. The identifier was our 7000 SP6M. The origin time was logged to the second at 21:24:30, Universal Coordinated Time, which is 5:24 in the afternoon and 30 seconds Eastern Daylight Time. The location was given as 34.1 degrees north latitude and 81.1 degrees west longitude. The agency described the location in plain English as 6 kilometers north-northeast of St. Andrews, South Carolina. St. Andrews is a census-designated place in eastern Richland County, immediately west of the Columbia city limits, immediately north of a large artificial lake that we will come to in a moment. The depth field of the entry, which on a real earthquake catalogue entry reflects the focal depth of the rupture in the crust, was logged as 0 kilometers. 0 kilometers means surface. 0 kilometers, in the language of the catalogue, means whatever this was happened in the air, and the magnitude field of the entry was given as 0.0. That has to land before we go any further. The magnitude scales the agency uses are calibrated to the energy released by seismic waves travelling through solid Earth. They are not designed for pressure waves travelling through air. When the agency wishes to log an atmospheric pressure event that was detected by its seismic network, meaning the ground shook because the air pushed it, the magnitude field has no physical meaning. So when the agency wants to log something like that in its catalogue, it manually assigns 0.0. It is a marker. It is a flag. It is the agency's way of saying, the catalogue detected this, but the catalogue cannot describe it with the numbers the catalogue normally uses. And then, In the event type field, the field where a real earthquake entry would say earthquake or aftershock or quarry blast or nuclear explosion, the agency typed 2 words, sonic boom. 2 words, sonic boom. Those 2 words sitting in the official earthquake catalogue of the United States Geological Survey, attached to a precise time and a precise location and a felt area that had already started ballooning across the Midlands, are the agency's formal admission that the seismic network of the United States picked up something at 5:24 on Thursday afternoon over central South Carolina, that whatever it picked up registered on the network in a way that resembled a real seismic event, but was not a real seismic event, and that the agency's best institutional interpretation of what it picked up was an atmospheric pressure pulse from above. What the agency did not type in any of the fields was an explanation of what caused the pulse. That gap, the gap between what the catalogue confirmed and what the catalogue did not explain, is the story. And in the next 2 hours, that gap was going to be filled in by hundreds of thousands of people on the ground, by federal agencies issuing carefully phrased denials, by NASA going on the record about what a meteor would have looked like and didn't, by Shaw Air Force Base going on the record about its own aircraft and what they were and weren't doing, and by another federal agency at McEntire Joint National Guard Base, 15 miles southeast of the catalogue location, not going on the record at all. By the time the sun came up on Friday morning, the official position of the United States government on what produced the loudest atmospheric event of the year over the Carolinas was as follows. It happened. It was not an earthquake, it was not a meteor, it was not a Shaw F-16, it was not a thunderstorm, and we do not know what it was. So what did happen at 21:24:30, Universal Coordinated Time on the 28th of May 2026 in the air, 6 kilometers northeast of St. Andrews, South Carolina? That is the question the catalogue asked the public, and we're going to spend the next 90 minutes putting the pieces together. We're going to look at the instrumental record of what actually happened. We're going to look at the ground underneath the location, because the ground underneath has been shaking for months in a way that ground in that part of the country is not supposed to shake. We're going to look at the lake immediately adjacent to the location, because the lake immediately adjacent has a history that very few people who heard the boom on Thursday afternoon are aware of, and the history is not a small detail. And we are going to look at the bases around the lake, because the bases around the lake are the only entities in the country with the operational capability to have produced the pressure wave that the catalogue logged. And the bases around the lake are doing 2 very different things in their public responses. And then we are going to come to the question that the catalogue entry itself is structured around. Because the kind of event the agency logged on May 28th can really only mean one of 2 things. Either the surface of the Earth in central South Carolina is doing something that the existing geophysical models do not yet have a clean category for, and what we are watching is the first formally catalogued instance of that phenomenon. Or the United States military, in the airspace over central South Carolina on the afternoon of May 28th, did something it has not chosen to disclose, and the catalogue entry is the only public trace it left. There is a third reading. We will come to the third reading. But the third reading is harder, and it is the reading the channel does not endorse, and it is the reading the data only partially permits. So we are going to start with the first 2. So, the minute the air hit. Let us walk through what actually happened on the ground. The first reports came in by group text within 90 seconds of the event. People in Columbia were asking each other if they had felt that. People in Casey were asking if a transformer had blown. People in Lexington were asking if a plane had crashed. People who were outside described it as a deep, low-frequency rumble that they felt in their feet and in their chest before they identified it as sound. People who were driving described it as a pressure change inside the car, a popping sensation in the ears that arrived a fraction of a second before any conscious recognition of sound. That description, the pressure change in the ears, is important. It is the description that distinguishes a real atmospheric pressure wave from a loud noise. The eustachian tubes equalize pressure between the inner ear and the outside environment, and when the outside pressure changes suddenly, the tubes register the change before the brain registers it as sound. The fact that multiple witnesses across multiple counties reported the pressure change in their ears as a precursor to the sound is a piece of physical evidence about what the event actually was. It tells you that what arrived first was not an acoustic signal, but a compression of the atmosphere. That is the signature of a real pressure event. And while those descriptions were being typed into group chats, the United States Geological Survey's Community Internet Intensity Map was already filling in. The map for the May 28th event registered intensity 6, over a footprint of more than 100 linear miles in multiple directions. The agency's plain English label for intensity 6 is strong shaking. The fact that more than 1,000 people independently submitted intensity reports describing strong shaking across that footprint for an event the agency itself has classified as a sonic boom and not an earthquake is, when you sit with it, one of the most informative data points in the entire catalogue entry. Because a typical sonic boom from a single supersonic aircraft does not produce a strong shaking footprint of 100 miles across. A typical sonic boom produces a felt corridor along the aircraft's ground track, with width determined by the altitude and the Mach number, typically 20 to 50 miles. The felt area is linear, not radial. It tracks the aircraft. The May 28th event did not follow that pattern. The Community Internet Intensity Map shows a roughly radial felt pattern centered tightly on the catalogued epicenter in Richland County and dropping off in all directions as a function of distance from the source. The geometry is what you would expect from a point source pressure release at or near the surface, not from a moving supersonic source at altitude. The maximum intensity at the center, intensity 6, is what you would expect from a meteoroid airburst of substantial energy at moderate altitude, or from a surface point source explosion of large equivalent yield, or from a very specific kind of atmospheric coupling to a very shallow seismic source, which is something we will come back to. What the geometry does not look like is the felt corridor of a fighter jet at altitude transiting through supersonic regime. Hold on to that detail. It will matter for everything that follows. By the time the first intensity map responses had been logged, the USGS had also published its automated alert tweet through its USGS Earthquake social media account. The tweet was formatted in the standard template the agency uses for every notable seismic event. For the May 28th event, the template populated as follows: notable quake, preliminary info, magnitude 0.0 sonic boom, 6 kilometers north-northeast of St. Andrews, South Carolina. That single post by the official seismic monitoring agency of the United States government, formatted in the exact template used for every real earthquake the agency catalogues, accumulated within the first 20 hours over 291,000 impressions, 238 reposts, 744 likes, and 46 replies. The reach of a single line of bureaucratic catalogue text is, by itself, a measurement of how much the event registered with the public. It also tells you something about how the public read the catalogue entry. The public read it as the official admission that the agency knew something had happened, knew it was not an earthquake, and was choosing to be precise about which category of thing it was not. The public read it correctly. That is what the entry meant, and then the entry stopped. The agency did not follow up with any explanation of the source. The agency did not issue a press release. The agency did not name a likely candidate mechanism. The agency posted the catalogue entry, retweeted it once, and said nothing else. Which is when, on Thursday evening and through the night and into Friday morning, the rest of the federal government started to fill in the picture by saying what the event was not. NASA was the first major agency to respond beyond the USGS. The space agency stated that the boom did not appear to have originated from space. The exact language was that NASA had no eyewitness reports of a fireball at the time and location of the event, and no satellite detections of a meteor over the area during the relevant minute. That statement carried specific informational weight because NASA has access to satellite sensors that are extremely good at detecting meteor airbursts, even in daylight. The geostationary lightning mapper instruments on the GOES weather satellites that hang over the Western Hemisphere are capable of detecting most bolides above a kinetic energy threshold of roughly 500 tons of trinitrotoluene equivalent, regardless of whether the airburst occurs in daylight or at night. The relevant threshold is well below the energy required to produce the felt intensity that the May 28th event produced on the ground. The American Meteor Society's public fireball event tracker, which accepts witness reports from across North America in real time, similarly had no entries for the relevant window. The Center for Near-Earth Object Studies Fireball database did not have an entry, and the United States Space Force, which tracks re-entering pieces of orbital debris, did not have a candidate object whose predicted re-entry footprint covered central South Carolina at the catalogue minute. The doorbell camera footage from Thursday evening that purported to show a meteor trail was investigated and identified as a high-altitude jet contrail. The geometry of the trail in the footage the speed at which it crossed the frame, and the angle of the apparent trajectory relative to the time of the boom were all inconsistent with a bolide entering the atmosphere. The trail was visible in the footage at a sustained moment in the frame, which is the signature of a jet aircraft's contrail at altitude, not the brief streak signature of a meteoroid. The doorbell camera meteor hypothesis was dead by Friday morning. Shaw Air Force Base was the next major federal entity to weigh in. Shaw is located in Sumter County, 80 kilometers east-southeast of the Catalog epicenter, and is one of the principal active-duty Air Force installations in the southeastern United States. Shaw is home to the 20th Fighter Wing, which operates F-16 Fighting Falcons. The Poinsett Electronic Combat Range, which is the principal supersonic training range in the central South Carolina airspace, is operated out of Shaw. On Friday morning, Shaw released a public statement confirming that no Shaw aircraft activity on Thursday evening could account for the boom. The exact phrasing matters. The base did not say that no Shaw aircraft were airborne. The base said that no Shaw aircraft activity could account for the boom. That phrasing leaves room for routine aircraft activity that was not supersonic, for aircraft activity in airspace that was not over the felt area corridor, and for activity that did not produce the kind of pressure wave required to generate the catalog entry. But the phrasing also makes a specific operational claim. The base is saying, on the public record, that the aircraft we had in the air were not flying in a regime or in a location that could have produced the pressure wave the USGS catalog logged. McEntire Joint National Guard Base did not issue a comparable statement. McEntire is the closest major military installation to the catalogued epicenter, at roughly 30 kilometers distance, and is operationally home to the 169th Fighter Wing of the South Carolina Air National Guard, which flies F-16s. The base did not publicly confirm or deny that its aircraft were airborne. The base did not publicly identify which aircraft were and were not flying. The base did not publicly characterize the operational status of its supersonic training activities for the relevant window. That silence is itself a data point. A base that knows its aircraft were not airborne would, in the normal operational pattern, say so. A base that knows its aircraft were airborne but were not flying supersonic would, in the normal operational pattern, say so. The absence of either statement is, by elimination, a third category of response, and we will come back to what that third category might mean. The Federal Aviation Administration similarly did not, in the publicly accessible Notice to Air Missions database for the relevant window on May 28th, post any advisory for supersonic operations in the corridor overlying the felt area of the boom. The administration did not publicly attribute the event to any commercial or general aviation operator. By Friday afternoon, the FAA had said, in effect, nothing at all about what produced the pressure wave that the USGS catalogue had logged on Thursday. So what is the official position of the United States federal government on the May 28th South Carolina sonic boom, as of the close of the briefing window for this video? The official position is that an atmospheric pressure event occurred at 5:24 in the afternoon on Thursday, that the event was felt across more than 100 linear miles of the southeastern United States, that the event was strong enough to register on the National Instrumental Seismic Network and be logged in the official earthquake catalogue, that the event was not an earthquake, that the event was not a meteor, that the event was not a Shaw F-16, and that beyond those denials, no federal agency has publicly attributed the event to any specific source. That is where this story sits. The cleanest single instance in the modern instrumental record of a felt East Coast mystery boom, formally entered into the official catalogue, with a precise time and a precise location, and a precise series of agency denials about what it was not, and no public statement from any official source about what it was. The question is, why is this happening here, and why is it happening now, and what does the absence of an official explanation actually mean? Because the location matters, and the geological backdrop matters, and the historical context of the immediate vicinity matters. The boom did not happen in a featureless suburb of a featureless city. The boom happened in a very specific place, on top of a very specific piece of ground, that has been doing very specific things for the past 5 years that the rest of the country has not been paying attention to. And 10 kilometers from the boom is a lake, and in the middle of the lake is an island, and the island has a name, and the name is going to tell you everything you need to know about why this story has the shape it has. Part 2. What the catalogue actually said. To understand what the United States Geological Survey was actually communicating when it published catalogue entry as 7000 SP6M on Thursday evening, you have to spend a few minutes with the structure of the catalogue itself because the structure of the catalogue determines what the agency could and could not say, and what it chose to say within those constraints. The Advanced National Seismic System is the federal program that operates the official earthquake catalogue of the United States. The program is administered by the USGS and integrates data from a network of seismic instruments distributed across the continent. When a seismic event occurs anywhere in the country, the automated processing pipeline detects the signal across multiple stations, calculates a preliminary location and magnitude based on arrival time differences and signal amplitudes, and posts a preliminary catalogue entry within minutes. Human analysts then review the automated entry, refine the location and magnitude, classify the event type, and confirm or modify the preliminary entry. The catalogue entry that the agency posted for the May 28th event went through that process. The automated pipeline detected a signal across multiple stations in the southeastern network. The signal arrived at the stations in a pattern that was consistent with a real source, rather than a noise artifact. The pipeline calculated a preliminary location, which was refined by the analyst to 34.1 degrees north and 81.1 degrees west. The pipeline calculated a preliminary depth, which was refined by the analyst to 0 kilometers. The pipeline assigned a preliminary magnitude, which the analyst manually overrode to 0.0. And the analyst entered the event type field as sonic boom. Each of those choices is a piece of communicated information. The location is precise to 4 significant figures. The network has enough stations in the southeastern United States to triangulate a surface or near-surface source to within roughly a kilometer of confidence under typical operating conditions, and the catalogue location sits squarely within Richland County, 6 kilometers north-northeast of the unincorporated community of St. Andrews. The location is not approximate, it is not a guess. It is the agency's best estimate of where the source of the signal that its network detected actually was. And the location, as we will come back to repeatedly, is on top of an active earthquake swarm corridor and 10 kilometers north of the dam at the eastern end of an artificial lake that we will be discussing in detail in a few minutes. The depth of 0 kilometers is the agency's formal way of saying that the source was at or above the surface of the Earth. The standard depth assignment for a small unlocated earthquake in the southeastern United States, when the depth cannot be precisely resolved, is typically a default value of 10 kilometers, because most earthquakes in stable continental interiors occur in the upper crust at depths between 5 and 20 kilometers. The agency did not assign the default depth. The agency assigned 0 kilometers, which is the formal flag for a surface or atmospheric source. That is the agency saying, the signal we detected did not originate underground. The magnitude of 0.0 is the formal flag for an event whose magnitude cannot be expressed on the standard scales used by the catalogue. The catalogue requires every entry to have a magnitude field. There is no null option, so when the agency wishes to log an atmospheric pressure event, the agency assigns the flag value of 0.0. The flag value is the agency's way of distinguishing real events of this kind from genuine micro-earthquakes in the lowest detectable magnitude range, which would be logged as magnitude 0.1 or 0.2 or higher. 0.0 is a special value. It is a manual flag. It is a label, not a measurement. And the event type field of sonic boom is one of the standardized values that the structured event type taxonomy accepts. The agency has a category for it. The category exists because the agency, over the long history of the National Seismic Network, has on rare occasions detected atmospheric pressure events that it has determined to be sonic booms, and the agency has needed a way to log those events in a structured way that distinguishes them from earthquakes while preserving the instrumental record. By selecting the sonic boom event type, the agency is communicating its best institutional interpretation of what its sensors saw. The agency is not saying it has confirmed the specific source of the boom. The agency is saying that the signal recorded by its network has the characteristics of an atmospheric pressure pulse, that the source was at or above the surface, and that the best category in the catalogue's standardized event type taxonomy for this signal is sonic boom. The agency is making a classification call based on the signal characteristics. The signal characteristics that distinguish a sonic boom from an earthquake are well established. An earthquake produces a wavefront that propagates through solid rock, with characteristic arrival times for the compressional primary wave and the shear secondary wave that are determined by the elastic properties of the crust. The primary wave arrives first because it travels faster, the secondary wave arrives several seconds later because it travels slower, and the time difference between the two arrivals is what allows seismic analysts to estimate the distance to the source. A sonic boom, by contrast, produces a pressure pulse that propagates through the atmosphere at the speed of sound. When the pressure pulse arrives at a seismic station, it shakes the ground around the instrument, and the instrument records the shaking. But the signal does not have the characteristic primary wave, secondary wave structure of a real earthquake. It has the characteristic structure of an atmospheric pressure pulse, coupling into the ground at the surface. The agency's analysts can distinguish between the two signal types in a routine review. That is what the analysts did on Thursday evening. They looked at the signal that the network recorded for event US 7000 SP6M. They identified the signal as having the characteristic structure of an atmospheric pressure pulse. They classified the event type as sonic boom. They assigned the flag magnitude of 0.0. They assigned the surface depth of 0 kilometers. They triangulated the source location to within instrumental precision in eastern Richland County, and they published the catalog entry. What the agency did not do, and what the agency could not do from the seismic signal alone, was identify the physical mechanism that produced the atmospheric pressure pulse. The seismic signal tells the agency what the signal looked like when it arrived at the network. The seismic signal does not tell the agency what produced the signal in the first place. The agency would need other information, from other sensor systems and from other agencies, and from the operators of any aircraft or vehicles that were in the airspace at the relevant time, to make that determination. And as of the close of the briefing window for this video, the agency has not made that determination publicly. The Community Internet Intensity Map for the event is worth a closer look, because it tells you what the ground response to the atmospheric pressure pulse actually was. The map shows 1,454 total responses, of which 1,449 were plotted across 120 geographic blocks. The plotted blocks are color-coded by maximum reported intensity on the modified Mercalli scale. The center of the map shows blocks colored at intensity 5 and intensity 6, with the densest cluster of intensity 6 reports concentrated within roughly 50 kilometers of the epicenter in Columbia, Casey, Sumter, and along the East 20 corridor. The blocks at the periphery, in the Greenville area to the west and the Charleston area to the southeast, show intensity 2 and 3. The overall geometry is a roughly circular footprint centered on the catalogued epicenter, with intensity dropping off as a function of radial distance, with some attenuation asymmetry that likely reflects local geological conditions and population density variations. That circular footprint is, again, not what a moving supersonic source at altitude produces. A moving supersonic source produces an elongated felt corridor along the aircraft's ground track. A high-altitude F-16 flying supersonic at 30,000 feet over central South Carolina would produce a felt corridor that would be roughly 20 to 40 miles wide and would extend along the entire length of the supersonic segment. The corridor would have a long, thin shape. It would have multiple intensity hotspots distributed along its length, where the boom carpet was directly under the aircraft, not a single intensity hotspot concentrated at one point. The May 28th event has a single intensity hotspot concentrated at the catalogued epicenter. The felt corridor is roughly circular, not elongated. The maximum intensity is at one point. That geometry is what a point source pressure release produces. A point source pressure release can come from a high-altitude meteoroid airburst, in which case the apparent source location on the ground would be the point directly below the airburst altitude. A point source pressure release can come from a surface explosion, in which case the source location would be the site of the explosion. A point source pressure release can come from an extremely shallow seismic source, whose energy couples efficiently into the atmosphere at the surface. The May 28th event has the geometry of a point source. The agency has classified the source as atmospheric. That narrows the candidate physical mechanisms. The candidate physical mechanisms for a point source atmospheric pressure release at the energy scale required to produce a 100-mile felt footprint with a maximum intensity of 6 are not numerous. We will come back to them in detail in the second half of this video. For now, the point worth holding on to is that the catalogue entry, taken on its own terms and read carefully for what it actually says, rather than what people on social media have assumed it says, communicates a specific and constrained physical interpretation. The agency saw a signal. The signal was real. The signal was atmospheric, not crustal. The signal originated from a point source. The agency does not know what the point source was. The agency has not received the necessary additional information publicly. The catalogue entry is also missing aftershocks. a real earthquake of sufficient magnitude to be felt by 1,000 people across 100 miles would, in essentially every case in the modern instrumental record, produce a detectable sequence of aftershocks in the hours and days following the main event. The May 28th event has produced no detectable aftershocks. The seismic network has been recording continuously since the event. No additional entries have appeared in the catalogue at or near the catalogue location in the hours following the boom. The absence of aftershocks is consistent with an atmospheric source. The absence of aftershocks is not consistent with a shallow seismic source large enough to produce the observed felt footprint. That is one of the strongest single pieces of evidence in favour of the agency's classification of the event as a sonic boom rather than as a shallow earthquake. But the absence of aftershocks does not tell you what produced the atmospheric pressure pulse. The absence of aftershocks only tells you that the pulse came from above the ground rather than from below it. The question of what produced the pulse remains open, and the question of why this is the first formally catalogued event of its kind in the modern instrumental record, when East Coast mystery booms have been reported for 2 centuries, is the question we're going to come back to repeatedly. Because the historical East Coast mystery booms, the Seneca guns of the Carolinas and the New York Finger Lakes, the modest noises of central Connecticut were never catalogued with this level of instrumental precision. They were reported by witnesses. They were investigated when they were investigated at all after the fact. They were never assigned an event identifier, a precise time, a precise location, a precise depth flag, a magnitude classification, and a community intensity map of the kind that our 7000 SP6M has. So when the agency formally entered the May 28th South Carolina event into the catalogue with all of those structured fields populated, the agency was, in effect, opening a new chapter in the documentation of East Coast mystery booms. The agency was creating the first formally instrumented case of a phenomenon that has been folkloric and unverified for 200 years. The agency was saying, for the first time on the official record, that this kind of event is real and is detectable by the National Seismic Network and is worthy of a catalogue entry. And the agency was inviting the next investigation to take what the catalogue now contains and build on it. That is what the catalogue actually said. The catalogue said this happened. The catalogue said this was not an earthquake. The catalogue said the source was atmospheric. The catalogue said the source was a point source, and the catalogue left the rest of the page blank for someone else to fill in. Part 3. The 3 things. It wasn't. The most useful way to understand what the May 28th South Carolina sonic boom was is to spend a few careful minutes walking through what the federal agencies have formally, and on the record, said it was not. Because each denial is precise, each denial is consequential, and the combination of the denials taken together defines the negative space that the actual answer must fit inside. The first denial came from the USGS itself, in the structure of the catalogue entry. The agency said, by the choice of event type, by the assignment of 0 depth, and by the manual override of the magnitude field to 0.0, that the event was not an earthquake. The signal characteristics on the National Seismic Network were inconsistent with a fault rupture in the crust. The signal characteristics were consistent with an atmospheric pressure pulse coupling into the ground at the surface. The agency classified the event as a sonic boom in the structured event type taxonomy. The agency, in the first hour after the event, ruled out the most obvious initial guess. That denial mattered because the initial public reaction to the event was overwhelmingly that an earthquake had occurred. Group texts across the Midlands were full of the question. Local news bulletins on Thursday evening initially reported the event as a possible earthquake. The agency's swift classification, within minutes of the catalogue entry being created, was the single piece of information that redirected the public conversation away from the earthquake hypothesis and toward the atmospheric hypothesis. That redirection happened because the agency made the classification call quickly and confidently, and because the agency's classification authority on seismic and atmospheric pressure events is institutionally trusted. But the agency, having ruled out earthquake, did not name an alternative cause. The agency only said what the event was not. And the public, presented with a confirmed atmospheric event and no identified source, did what the public always does in the absence of an official explanation. The public generated its own. The second guess, which materialized within hours of the catalogue entry being posted, was that the event was a meteor airburst. The hypothesis was supported initially by a piece of doorbell camera footage from a resident in the broader Columbia metropolitan area that appeared to show a bright trail in the upper portion of the frame around the time of the boom. The footage circulated rapidly on social media. By Thursday night, the meteor hypothesis had become the leading public explanation. NASA's response when it came on Friday morning was unambiguous. The space agency stated for the public record that no fireball had been observed at the time and location of the event, and that no satellite detection of a meteor over the area had been recorded during the relevant window. The statement carried specific weight because the agency has access to a constellation of satellite sensors that are extremely well suited to detecting meteor airbursts. The geostationary lightning mapper instruments on the Goose weather satellites monitor the upper atmosphere over the Western Hemisphere continuously and are capable of detecting bolides above an energy threshold of roughly 500 tons of trinitrotoluene equivalent, regardless of daylight or cloud cover. The relevant threshold is well below the energy required to produce the felt intensity that the May 28th event produced on the ground. If a meteor airburst of the energy scale required to produce a community intensity, 6 felt footprint across 100 miles had occurred over central South Carolina at 5:24 on Thursday afternoon, the geostationary lightning mapper would have detected it. The instrument did not. NASA said the instrument did not. That statement effectively closed the meteor hypothesis as a candidate explanation. The American Meteor Society's public fireball reporting system, which collects eyewitness reports from across North America and aggregates them into a public database in near real time, similarly had no entries for the relevant window. The Society's reporting system regularly receives hundreds of reports for any genuine fireball of substantial brightness, even in daylight. The system had effectively 0 reports of a fireball at the time and location of the May 28th event. The absence of eyewitness reports, combined with the absence of satellite detection, combined with the agency statement from NASA, combined with the identification of the doorbell camera footage as a high-altitude contrail rather than a meteor trail, produced a converging body of evidence against the meteor hypothesis from 4 independent sources by the end of Friday morning. So the meteor hypothesis, which had been the leading public explanation by Thursday night, was effectively dead by Friday afternoon. But the elimination of the meteor hypothesis did not produce an alternative explanation. The public presented with a confirmed atmospheric event, a denial of the earthquake hypothesis, and a denial of the meteor hypothesis, turned to the next most plausible candidate. The next most plausible candidate was an aircraft, specifically a military aircraft because the central South Carolina airspace is heavily used for military training operations, and the F-16 Fighting Falcon, which is the principal supersonic-capable fighter aircraft based at the relevant installations, is operationally capable of producing the kind of pressure wave that the USGS catalogue had recorded. The third hypothesis, the military aircraft hypothesis, was the one that local residents and online observers spent the most time examining in the hours following the event. South Carolina hosts multiple active military installations capable of supersonic operations. The state has a long history of military aviation activity going back to the First World War. The Lake Murray area itself, as we will discuss in detail later in this video, was a primary World War II bombing range for B-25 Mitchell crews. The contemporary operational picture includes Shaw Air Force Base in Sumter County, McEntire Joint National Guard Base in Eastover, and the Poinsett Electronic Combat Range on the Wateree River near Shaw, all of which conduct routine training operations involving supersonic-capable aircraft. Shaw Air Force Base released a statement on Friday morning. The statement was carefully worded. The base confirmed that no Shaw aircraft activity on Thursday evening could account for the boom heard across the Midlands. The exact phrasing matters. The base did not say that no Shaw aircraft were airborne on Thursday evening. The base did not say that no Shaw F-16s conducted any training operations on Thursday evening. The base said that no Shaw aircraft activity on Thursday evening could account for the boom. That phrasing leaves room for routine aircraft activity that was not supersonic, for aircraft activity in airspace that was not over the felt area corridor, and for activity that did not produce the kind of pressure wave required to generate the catalogue entry. But the phrasing also makes a specific and operationally meaningful claim. The base is saying, on the public record, that the aircraft we had in the air on Thursday evening were not flying in a regime or in a location that could have produced the pressure wave the USGS catalogue logged. McEntire Joint National Guard Base did not issue a comparable statement. McEntire is the closest major military installation to the catalogued epicenter at roughly 30 kilometers distance and is operationally home to the 169th Fighter Wing of the South Carolina Air National Guard, which flies F-16s. The base did not publicly confirm or deny that its aircraft were airborne. The base did not publicly identify which aircraft were and were not flying. The base did not publicly characterize the operational status of its supersonic training activities for the relevant window. That silence is a third category of response. A base that knows its aircraft were not airborne would have said so. A base that knows its aircraft were airborne but were not supersonic would have said so. A base that says nothing at all when a major catalogue entry has been generated by an event over its immediate airspace and the surrounding population has been asking questions, is doing something other than either of those two things. The base is exercising the institutional prerogative not to comment, which is the prerogative an installation has when the operational details of its activities on the relevant day are either still under internal review or are subject to operational security restrictions that prevent public disclosure. The Federal Aviation Administration similarly did not, in the publicly accessible Notice to Air Missions database for the relevant window, post any advisory for supersonic operations in the corridor overlying the felt area of the boom. That absence is informative. Military supersonic operations in special use airspace are typically scheduled with NOTAMs that are publicly searchable. The NOTAMs are how civilian operators are warned to avoid the affected airspace, and how the FAA discharges its statutory obligation to coordinate civil and military aviation. The absence of a posted NOTAM for the relevant window means either that no supersonic operations were scheduled in the public-facing system, or that supersonic operations occurred without the standard advisory being filed, or that the relevant supersonic operations were conducted in a manner that did not require a NOTAM because they fell within a continuous use special use airspace boundary, whose general supersonic authorization is publicly known. Each of those possibilities has different implications, so the third hypothesis is in an unresolved state at the close of the briefing window. Shaw has denied responsibility, McIntyre has said nothing, the FAA has posted nothing, and the public, having exhausted the three most obvious initial candidates, has been left with a confirmed atmospheric event and no identified source. That is the negative space that the rest of this video is built around. The event happened. It was not an earthquake, it was not a meteor, it was not a Shaw F-16, and no other source has been publicly identified. The catalogue entry exists, the intensity map exists, the felt footprint extends across more than 100 miles, hundreds of thousands of people felt it, and the federal government, as of the close of the briefing window, has formally said only what it was not. There are two possible explanations for that pattern of agency response, and they are the two explanations that the title of this video refers to. The first possible explanation is that the federal agencies do not know what the source of the event was, that the source was not produced by any agency or operator under federal authority, that the source is the result of a natural or quasi-natural physical process that is not yet adequately described by the standard categories the agencies use, and that the absence of an official explanation is the absence of an explanation rather than the suppression of one. The second possible explanation is that the federal agencies do know what the source of the event was, that the source was produced by an agency or operator under federal authority, that the relevant disclosure is being handled through internal channels that have not yet produced a public statement, and that the silence of McIntyre and the FAA, combined with the carefully phrased Shaw denial, represents an institutional response designed to acknowledge what can be acknowledged without disclosing what cannot. Both readings are partially supported and partially undermined by the available data. Both readings make different predictions about what will happen next. Both readings make different demands on the scientific community to explain, and both readings are sitting on top of a geological backdrop and a historical context that gives each of them a structural argument the other does not have. Because the location of the May 28th event is not arbitrary. The location is on top of an active earthquake swarm that has been producing detectable seismicity in central South Carolina for 5 years. The location is 10 kilometers from the largest artificial reservoir in the southeastern United States. The location is 15 kilometers from a chain of islands that were used as live-fire bombing ranges during the Second World War. The location is 30 kilometers from a base that flies F-16s. The location is 80 kilometers from another base that also flies F-16s, and an electronic combat range that authorizes supersonic training. The location is a piece of central South Carolina that has more layered military and geological history per square kilometer than almost any other comparably sized region in the southeastern United States, and the event that was logged on top of that location is now sitting in the federal catalogue with a precise time and an unexplained source. The place to start before we get to the lake and the bombs and the bases is the ground underneath the catalogue entry, because the ground underneath has been doing something for 5 years that almost nobody outside the southeastern seismology community has been paying attention to. Part 4. The Swarm that started in Elgin. To understand what the ground underneath central South Carolina has been doing for the past 5 years, you have to start with a small town northeast of Columbia called Elgin. Elgin sits in Kershaw County, about 20 miles up the interstate from the city. Most of the country has never heard of Elgin. Until late 2021, most of South Carolina hadn't given Elgin any particular thought either. Elgin was a small town in a part of the state that was not seismically interesting. The southeastern United States is not California. The southeastern United States is intraplate, meaning the crust there sits inside a tectonic plate rather than on the boundary between two plates, and intraplate seismicity is generally low and diffuse and unspectacular. South Carolina averages a handful of small earthquakes per year, almost all of them too small to be felt. The state's most famous historical earthquake, the Charleston event of August 31, 1886, was a major intraplate rupture estimated at magnitude 7 that killed dozens and damaged much of the city. But events of that scale in the southeastern United States are separated by intervals of centuries, and then, on December 27, 2021, the ground near Elgin moved. The first event was a magnitude 3.3 earthquake, which is the threshold at which an event becomes broadly felt by people in the immediate epicentral area. The event was followed within days by additional events of similar size, and within weeks by dozens of smaller events. By July 27th of 2022, 7 months after the first event, the seismic network had recorded approximately 70 earthquakes in the immediate Elgin area, with the largest reaching magnitude 3.6 on June 18, 2022. The pattern matched what seismologists call an earthquake swarm, which is a cluster of seismic events occurring within a relatively short time interval and a relatively small geographic area, without a single dominant event and without a clear decay pattern. Earthquake swarms are common in volcanic regions, in hydrothermal regions, in regions of fluid injection activity, and in reservoir-induced seismicity zones. But earthquake swarms in the southeastern United States, away from any active volcanic or fluid injection activity, are rare. The Elgin swarm continued through 2022 and into 2023. The rate of events declined over time, but did not stop. Through 2024, additional events continued to be catalogued. Through 2025, the swarm continued. By early 2026, the cumulative count of earthquakes recorded in the Elgin area swarm since December 2021 had exceeded 200, making it the largest sustained intraplate earthquake sequence in the southeastern United States in the modern instrumental record. More than 200 earthquakes, sustained over more than 4 years, in a part of the country where the baseline expectation is a handful of small events per year, that is a substantial departure from the historical seismic pattern of the region, and it is happening by every available analysis along a strand of the Eastern Piedmont Fault System. The Eastern Piedmont Fault System is a late Paleozoic dextral strike-slip fault network that runs from Georgia through the Carolinas into Virginia, striking northeast to southwest. The fault system was formed during the Alleghenian orogeny, which is the mountain-building event that produced the Appalachian Mountains roughly 300 million years ago. During the orogeny, the African plate collided with the North American plate. The collision produced enormous shear stresses across the eastern margin of what is now the southeastern United States, and the shear stresses produced a network of strike-slip faults that accommodate the relative motion of crustal blocks along the collision boundary. After the collision ended and the continents subsequently rifted apart to form the Atlantic Ocean, the fault network became largely inactive. The faults are old, they are large, they cut through hundreds of kilometers of crust, and for most of the past 100 million years they have not produced significant seismic activity. But the faults are still there. The crust along the faults is mechanically weaker than the surrounding rock, and under the right stress conditions the faults can be reactivated. The Elgin swarm of 2021 to the present is sitting on top of one of those reactivated strands. A 2023 abstract presented at the Geological Society of America Southeastern Section meeting by researchers from the University of South Carolina specifically identified the Elgin swarm as occurring along a branch of the Eastern Piedmont Fault System and analyse the focal mechanisms of the catalogued events as consistent with reactivation of the strike-slip structure under the present-day intraplate stress regime. So the Elgin events are not random. The Elgin events are happening along a known geological structure, and the structure is one that has been seismically reactivated in the past. The question that the Elgin swarm has posed to the southeastern seismology community is why now? There are several candidate explanations. The first is that the swarm is the natural variability of an intraplate fault system that produces occasional clusters of activity at intervals that the modern instrumental record is too short to characterize. The second is that the swarm is the result of stress migration along the broader fault network, possibly related to slow long-term adjustments of crustal stress fields in response to glacial isostatic rebound or other large-scale processes that operate on geological timescales. The third is that the swarm has a local trigger, possibly related to fluid injection, groundwater redistribution, or surface loading by reservoirs and other engineered structures in the region. The third reading is the one that has the most direct relevance to the May 28th boom story, because the third reading is the reading under which a similar mechanism could be operating elsewhere in the Eastern Piedmont system, and as we'll see in the next part of this video, a similar mechanism may in fact be operating elsewhere in the system, specifically at Lake Murray, which is the artificial reservoir immediately south of the location where the May 28th sonic boom was catalogued. The intellectual ancestor of the third reading has a long history in the southeastern United States, and that history begins with another reservoir in another county in the same state, about an hour northwest of Elgin, called Monticello. Monticello Reservoir is an artificial lake that was filled beginning in December 1977 as part of the Virgil C. Summer Nuclear Generating Station project in Fairfield County. The lake covers approximately 6,700 acres. The Monticello Reservoir was filled rapidly, and within days of the first significant water impoundment, the area around the reservoir began producing detectable seismic activity that had not been present before. Over the next several years, more than 10,000 earthquakes were recorded in the immediate vicinity of the reservoir, the vast majority of them small but several large enough to be felt by nearby residents. The seismicity decayed gradually over the subsequent decade but did not disappear, and the Monticello Reservoir area has continued to be a low-level source of intraplate seismic activity for the past 4 decades. The Monticello case was studied in detail by a research group led by Pradeep Talwani at the University of South Carolina. Talwani and his colleagues established, in a series of papers in the 1980s and 1990s, that the Monticello seismicity was the result of a mechanism called reservoir-induced seismicity. The mechanism operates through 2 coupled effects. The first effect is the weight of the impounded water column itself, which increases the vertical stress on the crust beneath the reservoir. The second effect, and the more important of the two, is the infiltration of water from the reservoir into pre-existing fault zones in the underlying crust. The infiltration occurs through fractures and faults that intersect the lake bed, and the water pressure in those fractures increases over time as the reservoir continues to provide a hydrostatic head. Increasing pore fluid pressure in a fault zone reduces the effective normal stress on the fault, which reduces the frictional resistance to slip, which makes it easier for the fault to slip under the existing tectonic stress conditions. Faults that were previously locked because the frictional resistance was high can begin to slip in small increments once the pore fluid pressure rises above a critical threshold. The slip produces small earthquakes. The earthquakes propagate slowly through the fault network as the water continues to infiltrate, and the result is a sustained earthquake swarm that can continue for years or decades after the initial reservoir filling. The Talwani group established this mechanism rigorously for Monticello and established Monticello as one of the textbook cases of reservoir-induced seismicity in the global literature, alongside the Koyna Reservoir in India and a handful of other documented cases worldwide. The relevance of the Monticello case to the May 28th story is that the Eastern Piedmont Fault System runs through both the Monticello Reservoir area and the Lake Murray area. The same fault system, the same crustal stress regime, the same general intraplate geological context. Lake Murray is much larger than Monticello, with a surface area of 50,000 acres versus Monticello's 6,700. Lake Murray is older, having been impounded in 1930 rather than 1977, which means the reservoir-induced seismic response, if it occurred at Lake Murray, would have occurred decades ago and might or might not still be producing detectable activity. The seismic instrumental record for the Lake Murray area in the 1930s and 40s is essentially non-existent, so we cannot tell whether Lake Murray produced an analogous burst of activity when it was first filled. But the underlying geology and the underlying fault system are comparable, and the mechanism that Talwani documented at Monticello is in principle available at Lake Murray. And the second swarm that has been recorded in the South Carolina Midlands is centered not on Elgin but on the Lake Murray and Lexington area, which brings us to the next part of the story. Part 5. The second swarm at Lake Murray. In February and March of 2026, 3 months before the sonic boom event, the South Carolina Midlands started producing earthquakes in a second corridor. The second corridor was not centered on Elgin. The second corridor was centered on the Lake Murray and Lexington area, about 30 miles west of the Elgin swarm and immediately south and southwest of the location where the sonic boom would later be catalogued. The strongest single event in the second swarm was a local magnitude 3.0 earthquake on February 26, 2026, with the epicenter located approximately 2.5 miles from Lexington. The event was widely felt across the Midlands. It was followed by additional smaller events on March 19th and on subsequent dates through April and into May. By the second week of April, South Carolina had recorded 5 earthquakes in a 30-day window, which was the highest rate of seismicity for the state in any 30-day window since modern instrumental records began. 5 earthquakes in 30 days, in a state whose baseline seismicity rate has historically averaged a handful of events per year. The South Carolina Department of Natural Resources Geological Survey publicly characterized the activity as part of the broader Midlands earthquake sequence and noted that the 2 swarms, the Elgin sequence to the northeast of Columbia and the Lake Murray sequence to the west, appeared to be statistically related but spatially distinct. The 2 swarms together represent the most active sustained seismic period in the modern instrumental record of the state. The activity has continued at low rates into May, with additional small events catalogued in the Lake Murray and Lexington corridor in the weeks leading up to the May 28th boom, and the location of the May 28th sonic boom is directly inside the second corridor. The catalogue location for a 7000 SP6M sits within roughly 15 kilometers of the epicenter of the February 26th magnitude 3.0 event. The catalogue location sits within the broader Lake Murray to Lexington seismic activity corridor that has been producing detectable earthquakes for the previous 3 months. The spatial coincidence is direct, and it is not subtle. The question of what the spatial coincidence means is open. There are at least 3 possible interpretations. The first is that the spatial coincidence is genuinely coincidental, that the sonic boom is unrelated to the earthquake swarm, that the source of the boom is something external that happened to occur over a piece of the Midlands, where the ground has separately been doing something seismically interesting. This is the null hypothesis. It is a plausible interpretation. The second possible interpretation is that the spatial coincidence reflects a shared underlying physical mechanism. Under this interpretation, the earthquake swarm and the sonic boom are connected through the same set of crustal processes that have been activating the Eastern Piedmont fault system in the area, and the sonic boom is a particularly visible expression of the broader stress redistribution that is also producing the earthquakes. The specific mechanism by which a stress redistribution in the crust would produce an atmospheric pressure pulse is not obvious, and we will need to spend some time walking through the candidate mechanisms. But the spatial coincidence is suggestive, and the Moodus precedent in Connecticut demonstrates that shallow crustal events can in some specific cases produce atmospheric pressure responses through direct surface coupling. Whether the May 28th boom is such a case is the question. The third possible interpretation is that the spatial coincidence is meaningful but operates differently. Under this reading, the sonic boom is not the result of the earthquake swarm, but rather the earthquake swarm, and the sonic boom are both expressions of a third underlying process whose physical character we are not yet able to identify. This is the most speculative interpretation, and it is the interpretation that is hardest to test against the available data, but it is the interpretation that the historical East Coast mystery boom literature, taken at face value, leaves room for. Each of these 3 interpretations is partially supported by the available data and partially undermined. The first interpretation has the strongest prior probability simply because true coincidences are more common than people generally assume. But the coincidence interpretation has to explain why the felt area footprint of the boom is so closely centered on the active swarm zone, why the precision of the spatial overlap is at the kilometer level rather than at the regional level, and why the agency chose to classify the event with such precision rather than letting it sit as an unverified report. The second interpretation has the strongest theoretical appeal because it offers a natural explanation for the spatial coincidence and because it connects directly to the documented Moody's mechanism. But the second interpretation has to explain why the catalogue entry was classified as sonic boom and not as shallow earthquake, why the depth was logged as 0 kilometers rather than as a small positive value, why no detectable seismic component was recorded along with the atmospheric component, and why the historical Moody's events were not accompanied by atmospheric pressure releases of comparable felt area magnitude. The Moody's mechanism produces a localized atmospheric perception of a boom, typically felt within a few kilometers of the very shallow epicenter, not a strong shaking footprint extending across 100 miles. The May 28th event is several orders of magnitude larger than a typical Moody's event. The third interpretation has the appeal of explanatory flexibility, but the disadvantage of being difficult to test. By definition, an unknown process is one whose physical character we cannot yet specify, and the third interpretation amounts to a placeholder for a category of explanation that we have not yet developed. So where does that leave us? The honest answer is that the data does not yet adjudicate among the three interpretations. The spatial coincidence is real. The Eastern Piedmont Fault System has been producing unusual seismic activity in the area for 5 years. The May 28th boom occurred directly inside that activity corridor. The boom was classified as atmospheric and not crustal by the agency that has the instrumental authority to make the classification. And the question of whether the boom and the swarm share a physical mechanism, or whether they are coincidentally co-located, or whether they are both expressions of a process the standard categories do not yet describe, is the question that the next several events in the area will help to resolve. The relationship between the boom and the swarm is the structural backbone of the seismo-atmospheric reading of the event. If the boom and the swarm are connected through a Moody's-style coupling mechanism, the May 28th event becomes the cleanest single instrumental instance of a phenomenon that the southeastern seismology community has not previously been able to study in detail. If they are not connected, the boom becomes a freestanding event whose explanation has to be found elsewhere. The military activity reading of the event, which we will come to in detail later, does not require any specific relationship between the boom and the swarm. So when we say that the May 28th event can only mean two things, what we mean is that the available evidence narrows the candidate explanations to two main families: the seismo-atmospheric family, which treats the boom as a natural phenomenon, expressing some kind of crustal atmospheric coupling along a reactivated intraplate fault system, and the undisclosed military family, which treats the boom as the result of an aviation or weapons activity that has not been publicly attributed. Each family has multiple specific sub-hypotheses within it. Each family has specific predictions about what we should expect to see if it is the correct family, and each family has its own internal tensions and its own gaps that the available data does not fully close. Part 6. The Eastern Piedmont Fault System. The Eastern Piedmont Fault System is one of the great unsung structural features of the eastern United States. It is a network of strike-slip faults that runs from central Georgia through the Carolinas into Virginia, striking northeast to southwest. The Piedmont is the gently rolling upland region that sits between the Atlantic coastal plain to the east and the Blue Ridge Mountains to the west. It is underlain by some of the oldest rocks in the continent, dating from the Paleozoic era. The most important plate tectonic event for the Eastern Piedmont Fault System was the Alleghenian orogeny, which is the final phase of the long process by which the Appalachian Mountains were assembled. The Alleghenian orogeny began roughly 320 million years ago and continued for about 50 million years. During the orogeny, the African plate collided obliquely with the eastern margin of what is now North America. The oblique convergence produced shear stresses across the collision boundary, and the shear stresses produced a network of strike-slip faults that accommodated the relative motion of crustal blocks parallel to the boundary. The faults are dextral, meaning right lateral. The faults are large, with the principal strands cutting through hundreds of kilometers of crust to depths of 40 kilometers or more. After the breakup of Pangaea, which began around 200 million years ago, the eastern margin of North America became a passive continental margin, meaning the margin is no longer a plate boundary and no longer experiences direct tectonic stresses from a converging or diverging plate. Passive continental margins are generally seismically quiet because the stresses that drove fault activity during the active phase of plate convergence are no longer present. The Eastern Piedmont Fault system has been mostly quiescent for the past 200 million years, but the faults are still there, and the stress conditions on a passive margin are not zero. The eastern margin of North America experiences a small but non-zero compressive stress oriented roughly east-west, the result of the long-term spreading of the mid-Atlantic ridge to the east. Over geological time scales, this stress can accumulate enough strain to produce occasional reactivation events on the pre-existing fault network. The reactivation events are typically small, but they are detectable, and they are recorded in the historical seismic catalogue of the eastern United States. The most famous historical reactivation event on the broader southeastern fault network is the Charleston earthquake of August 31, 1886. The Charleston event, estimated at magnitude 6.9 to 7.3 by various modern reanalyses, was the largest intraplate earthquake in the eastern United States in the modern instrumental era. The event killed dozens of people, destroyed or damaged most of the buildings in central Charleston, and produced damage across an area of more than 1 million square kilometers. The mechanism of the Charleston event remains a subject of active research, with some studies attributing the event to reactivation of a fault in the broader Eastern Piedmont Fault system under the present-day intraplate stress field. The Charleston event sits in the modern seismic record as a reminder that the southeastern United States is not, in fact, seismically inert, and that the intraplate fault network is capable of producing major events at intervals that the short modern instrumental record cannot fully characterize. The Elgin sequence beginning in December 2021 and the Lake Murray sequence beginning in early 2026 together represent a substantial departure from the baseline. The combined rate of events in the two swarms over the past 5 years exceeds the historical baseline by an order of magnitude or more. What is producing the departure from the baseline is the question the southeastern seismology community has been working on since the Elgin swarm first appeared. There is no consensus answer yet. The reservoir hypothesis is the most relevant of these to the May 28th boom story, because it is the hypothesis that connects the Lake Murray swarm corridor most directly to a specific local triggering mechanism. The Talwani group's work on the Monticello Reservoir established that artificial reservoirs in the southeastern Piedmont can in principle induce seismicity in the underlying fault network, and the geological context of Lake Murray is comparable to Monticello in the key respects. The current Lake Murray swarm, which began in February 2026, raises the question of whether something has recently changed in the Lake Murray hydrological or stress environment that would produce a delayed or renewed reservoir-induced response. The lake has been filled since 1930, so the initial reservoir loading is presumably long since complete. But the lake is operated for hydroelectric generation, which means the water level varies seasonally and interannually in response to operational demand and rainfall variability, and the variation in the water level can, in principle, continue to produce changes in the stress field beneath the lake bed over time. The current lake level for May 2026 is at the upper end of the operational range, reflecting the wetter conditions in the eastern United States over the past several months. Whether the current high lake level is producing a renewed reservoir-induced response in the underlying fault network is an open question that the available data is not sufficient to fully address. What we can say is that the geological backdrop is plausible. The Eastern Piedmont Fault system is present, the reservoir is large and old, the mechanism that could in principle produce reservoir-induced seismicity is documented, and the current swarm activity is occurring directly above the relevant fault zone. The combination of these factors makes the Lake Murray area a reasonable candidate for sustained intraplate seismic activity for the foreseeable future, and the May 28th boom, if it is connected to the seismic activity through a Moodus-style coupling mechanism, would be one expression of the broader activity pattern. But we do not yet know whether the boom is connected to the seismic activity through any such mechanism. The catalogue entry for the boom does not include any seismic component. The Moodus precedent in Connecticut involves a small but detectable seismic signature that the South Carolina event does not exhibit. So while the geological backdrop is plausible for a seismo-atmospheric coupling mechanism, the instrumental record of the May 28th event itself does not directly support that mechanism. The seismo-atmospheric reading remains open, but it is not strongly supported by the specific catalogue entry. That tension between the plausibility of the geological backdrop and the absence of direct seismic evidence in the catalogue entry for the boom is what makes the May 28th event genuinely interesting. The setting is right for a seismo-atmospheric coupling mechanism. The setting is also right for a coincidental occurrence of an external pressure source over a piece of geology that has been independently producing earthquakes. The setting does not, by itself, resolve which of the two readings is correct. Part 7. Bomb Island, Doolittle Island, Lunch Island. To understand the second reading of the May 28th event, the undisclosed military reading, you have to spend some time with the historical depth of military activity in the immediate Lake Murray area. Because the Lake Murray area is not just a recreational reservoir in the South Carolina Midlands. The Lake Murray area is one of the most heavily worked pieces of land in the southeastern United States from a military history perspective, and the history is hiding in plain sight in the names of the islands in the middle of the lake. The lake itself was created in 1930 by the completion of the Drea Shoals Dam on the Saluda River. The dam was built by the South Carolina Power Company as a hydroelectric generation project. At the time of its completion, the Drea Shoals Dam was the largest earthen dam in the world by volume of fill material, and the impoundment behind the dam covered approximately 50,000 acres of the Saluda River Valley across portions of Richland, Lexington, Saluda, and Newbury counties. The lake was originally called Lake Murray after William Burroughs Murray, the chief engineer who designed the dam, and the name has been retained continuously since. The lake had been in existence for 12 years when the United States entered the Second World War in December 1941. Within months of Pearl Harbor, the United States Army Air Forces were rapidly expanding their training infrastructure across the country, and the southeastern United States was a particularly attractive region for training operations because of the favorable weather and the availability of large undeveloped land areas. The Columbia Army Air Base, located approximately 10 miles southeast of Lake Murray, was activated in early 1942 as a training center for medium bomber crews flying the North American B-25 Mitchell, a twin-engine medium bomber that had entered service in 1941 and would become one of the iconic American aircraft of the war. The Columbia Army Air Base needed bombing practice ranges within reasonable flight time. The Air Force selected 3 islands within Lake Murray for use as live-fire bombing ranges, leasing the islands from the South Carolina Power Company beginning in 1942. The 3 islands were Lunch Island, Shoal Island, and Drea Island. The names of the islands at the time were the pre-existing geographic names that the islands had carried since the lake was first filled in 1930, drawn from the names of the original landowners whose property had been inundated by the creation of the lake. The B-25 crews at the Columbia Army Air Base began flying training missions over Lake Murray in early 1942. The training involved dropping practice ordnance on the 3 islands and scoring the strikes from the air. The practice ordnance was loaded with white sand rather than explosive filler, which produced a visible dust cloud on impact against the red clay soil of the islands and allowed the bombardiers to visually assess the accuracy of their drops from the aircraft. Some training missions also involved live ordnance, including incendiary bombs and demolition ordnance. Over the course of 1942 through 1945, thousands of training missions were flown over Lake Murray by B-25 crews from the Columbia Army Air Base and from other bases that used the Lake Murray ranges. One of the units that trained over Lake Murray in early 1942 has a specific place in American military history. In February and March of 1942, 16 B-25 crews under the command of Lieutenant Colonel James H. Doolittle of the United States Army Air Forces conducted a final phase of preparation for a special mission whose target had not yet been disclosed to the crews. The specific phase of preparation that involved Lake Murray was a series of bombing practice runs from low altitudes against simulated targets that approximated the dimensions of Japanese military installations. On April 1, 1942, the 16 B-25 aircraft and their crews were loaded onto the deck of the United States Navy aircraft carrier USS Hornet at Naval Air Station Alameda in California. The Hornet steamed westward into the North Pacific. On April 18, 1942, the 16 aircraft were launched from the deck of the Hornet at a position approximately 650 miles east of the Japanese home islands. The aircraft flew westward at low altitude across the Pacific and conducted the first American air attack on the Japanese home islands of the Second World War, striking targets in Tokyo, Yokohama, Yokosuka, Nagoya, and Kobe. The raid is known in American military history as the Doolittle Raid. The crews of the Doolittle Raid had practiced at Lake Murray, not exclusively, and not as the only training site, but as a documented part of their preparation. The connection between Lake Murray and the Doolittle Raid is not folklore. It is documented institutional history. After the war, in the years following 1945, the local communities around Lake Murray began to refer to Lunch Island informally as Bomb Island, in recognition of the wartime use of the island as a bombing practice target. The informal name became increasingly common in local usage through the 1950s and 60s, and by the late 20th century the name Bomb Island had largely replaced Lunch Island in everyday reference. The island also acquired an alternative name, Doolittle Island, in honour of the connection between the Lake Murray training and the Doolittle raid. The two names, Bomb Island and Doolittle Island, are now both in current use, with local guidebooks and recreational maps using one or the other, depending on context. The original name Lunch Island has largely fallen out of common use. A historical marker commemorating the Lake Murray bombing range operations was erected at the lakeshore in 2007 by the Lake Murray B-25 Rescue Project, a non-profit organisation established to recover the wreckage of B-25 aircraft that had been lost in the lake during the war. The history matters for the May 28th boom story, not because anything about the Doolittle raid is directly connected to a contemporary military activity in the Lake Murray area, but because the Lake Murray area has a structural identity as a location that the United States military has historically used for ordnance training and that the United States military continues to operate in and around. The contemporary picture includes McEntire Joint National Guard Base, 15 miles southeast of Columbia, Shaw Air Force Base in Sumter County, the Poinsett Electronic Combat Range, and other installations and ranges across the central South Carolina region. The contemporary picture sits on top of the historical pattern, and the historical pattern is one of dense military activity in the broader Lake Murray and central South Carolina airspace for more than 80 years. That historical depth is the structural argument that the undisclosed military reading of the May 28th event rests on. The reading is not that the contemporary military is conducting activities that are operationally connected to the wartime Doolittle raid training. The reading is that central South Carolina has been a heavily worked piece of military training real estate for a very long time, that the operational use of the airspace and the lake area has continuity across multiple generations of activity, and that the May 28th event sits inside a broader pattern of ongoing military operations, whose specific details are not always publicly disclosed. The reading does not require a specific cover-up of the May 28th event in particular. The reading requires only that the institutional pattern of how the military operates in the area produces occasionally events whose public-facing acknowledgement is less complete than the events themselves are. Whether that is the correct reading for the May 28th event specifically is the question. The available evidence is consistent with the reading. The available evidence is also consistent with the alternative readings. But the historical depth is real, and the historical depth is the context within which the public reaction to the event has formed. Part 8. The 5 Bombers That Never Came Back. There is a piece of the Lake Murray wartime history that is worth sitting with for a moment, because it tells you something about how military operations over the lake have, historically, sometimes ended in ways that the official record did not initially fully acknowledge, and that subsequent investigation has had to recover by going underwater and looking at the wreckage on the lake bed. Between 1942 and 1945, 5 B-25 Mitchell bombers crashed into Lake Murray during training operations. The exact circumstances of the crashes vary. Some involved mechanical failures on takeoff or in flight. Some involved pilot error during low-altitude approach runs. Some involved unspecified incidents that the official accident reports of the period did not fully document. The cumulative loss of 5 medium bombers at a single training facility over a 3-year period was substantial, even by the standards of wartime training operations. 4 of the 5 aircraft were salvaged from the lake during the war or shortly afterward. The 5th aircraft, a B-25C variant, was not salvaged at the time and remained on the lake bed for the next 60 years. The location of the wreckage was generally known in local law but had not been formally documented or recovered. In 2005, a non-profit organisation called the Lake Murray B-25 Rescue Project was formed for the specific purpose of locating and recovering the wreck. The project successfully raised the airframe from the lake bed in September 2005. The recovered airframe was restored over the following several years and is currently maintained as a flying display aircraft. The 5 lost bombers are a reminder that operational activities over Lake Murray, conducted under the authority of the United States military and with the official sanction of the relevant federal agencies, have occasionally produced consequences that the official record at the time did not fully document. 4 of the 5 wrecks were recovered during or shortly after the war, but the recoveries were conducted under wartime conditions and the records of the recoveries are incomplete. The fifth wreck sat on the lake bed for 60 years before it was recovered, and the institutional knowledge of its location had been preserved primarily through local oral history rather than through official documentation. The institutional pattern is one in which the day-to-day, operational details of military activity over the lake are not always fully recorded in publicly accessible archives, and in which the public-facing acknowledgement of the activity is, sometimes, partial. That pattern is the structural argument for the undisclosed military reading of the May 28th event. The argument is not that the contemporary military is operating in the same way the wartime military operated. The argument is that the operational culture of military activity in the Lake Murray area has, historically, included a pattern of partial disclosure, and that the public-facing response to events that are operationally connected to military activity has, historically, been less than complete. Whether that pattern is operating in the case of the May 28th event specifically is the question. The available evidence does not adjudicate. The pattern is, however, part of the context. Part 9. The bases around Columbia today. The contemporary military operational picture in the central South Carolina region is dense and active. The principal active duty installation in the immediate area is Shaw Air Force Base, located near Sumter in Sumter County, approximately 80 kilometers east-southeast of the catalogued May 28th boom epicenter. Shaw is home to the 20th Fighter Wing, which operates F-16 Fighting Falcon aircraft, and to the Headquarters Air Force's Central Command. Shaw is one of the largest active-duty Air Force installations in the southeastern United States. The Poinsett Electronic Combat Range, located near Shaw, on the Wateree River, is the principal training range used by Shaw aircraft for supersonic and electronic combat training. The range is part of the broader Special Use Airspace structure, managed by the Federal Aviation Administration in coordination with the United States Air Force, and the range is authorized for supersonic operations within specified altitude and operating windows. Shaw aircraft routinely use the Poinsett range for training, and the training operations occasionally produce sonic booms that are felt in the surrounding civilian communities. The Air Force has a public affairs apparatus that issues notifications when supersonic training is planned, and the apparatus generally responds to public inquiries about specific events with confirmation or denial of operational responsibility. The South Carolina Air National Guard operates from McEntire Joint National Guard Base in Eastover, approximately 15 miles southeast of the city of Columbia and 30 kilometers from the catalogued May 28th boom epicenter. The principal flying unit at McEntire is the 169th Fighter Wing, which operates F-16s. The operational tempo at McEntire is substantial, with the wing maintaining the standard readiness posture of an air defense alert unit. The Federal Aviation Administration coordinates civil and military aviation in the central South Carolina airspace through the standard structure of special use airspace, military operations areas, restricted areas, and warning areas. The structure includes multiple supersonic training areas at altitudes above 30,000 feet. The combination of Shaw, McEntire, the Poinsett Range, and the broader special use airspace structure makes central South Carolina one of the more heavily used military training environments in the southeastern United States. The density is the reason supersonic events in the area are not uncommon historically, although the public-facing reports of such events typically come with formal notams and with subsequent attribution to the relevant operating unit. What is unusual about the May 28th event is the absence of those normal accompaniments. There was no posted notam for the relevant window. There was no formal attribution to a specific unit. The two principal candidate operators, Shaw and McEntire, have produced responses that are asymmetric in a way that is itself a piece of information. Shaw has formally denied. McEntire has formally said nothing. The asymmetry is what the undisclosed military reading of the event rests on. There are several ways to interpret the asymmetry. One interpretation is that Shaw, having been the first installation to be asked, took the lead on the public response, and that McEntire, not having been asked or not having received approval to respond, simply has not commented yet. Under this interpretation, the asymmetry is procedural rather than substantive. A second interpretation is that McEntire is conducting an internal review of its operations on the relevant afternoon before making a public statement, and that the statement, when it comes, will either confirm or deny McEntire involvement based on the outcome of the review. A third interpretation is that McEntire's silence reflects a more substantive operational reality. in which the base either was or might have been involved in activity on the relevant afternoon, whose public-facing disclosure is being handled through channels other than a public press statement. Under this interpretation, the asymmetry is itself the disclosure. The available evidence does not adjudicate among the three interpretations. Each is consistent with the data. Each makes different predictions about what the next several days and weeks will look like. The first and second interpretations predict that a McIntyre response will eventually emerge that either confirms or denies the base's involvement. The third interpretation predicts that no such response will emerge, or that any response that does emerge will be carefully limited in its informational content. The future record will help to distinguish among the interpretations. The broader question of what the undisclosed military reading actually implies, if it is correct, is the question we should sit with for a moment. Because the undisclosed military reading is not a single hypothesis. It is a family of hypotheses, and the family includes possibilities that range from the mundane to the substantial. The most mundane version of the undisclosed military reading is that an aircraft from McIntyre, or from another base in the region, conducted a supersonic transit at altitude over central South Carolina on Thursday afternoon, that the transit was not posted as a NOTAM because it fell within a continuous use special use airspace boundary whose general authorization is publicly known, and that the responsible operator has not yet been formally identified because the standard institutional process for that identification takes time. Under this reading, the May 28th event is a routine supersonic training event that produced an unusually large felt footprint due to atmospheric conditions, aircraft altitude, or some combination of factors that amplified the ground response. The reading is consistent with the available evidence except for one important detail, which is the geometry of the felt area. The radial rather than linear felt geometry is not what a single, supersonic aircraft at altitude would produce, so the mundane version has to either explain the geometry through some atmospheric mechanism or accept that the geometry is anomalous. A more substantial version of the undisclosed military reading is that the May 28th event involved multiple aircraft in coordinated supersonic operation, that the coordination produced a more diffuse felt pattern than a single aircraft would have, and that the operational details of the coordination are subject to standard military operational security restrictions that prevent public disclosure. Under this reading, the event is a coordinated training event that the relevant agencies are not currently choosing to fully describe. The reading explains the geometry better than the mundane version does, but it requires a coordinated operation of a kind that is uncommon over civilian airspace and would normally be subject to substantial advanced coordination with the FAA. A still more substantial version of the undisclosed military reading is that the May 28th event involved an activity other than routine supersonic training, that the activity is operationally sensitive enough to require complete public-facing silence, and that the catalogue entry and the agency denials together represent the federal government's chosen public-facing response to the event. Under this reading, the event is a non-routine activity whose nature is not currently being disclosed. The reading is the one that is hardest to falsify, because it does not specify what the activity actually is. The channel does not endorse any specific version of the undisclosed military reading. The available evidence is consistent with all three versions, and the available evidence does not provide a way to discriminate among them. Part 10. Reading 1. Seismo-atmospheric coupling. So let us now turn to the first of the two main readings of the May 28th event, and walk through what the reading actually says, what it predicts, and where the available evidence supports it and where it falls short. The seismo-atmospheric coupling reading begins with the spatial coincidence between the May 28th boom and the active South Carolina earthquake swarm. The catalogued boom location sits inside the broader Lake Murray to Lexington seismic activity corridor that has been producing detectable earthquakes since February 2026. The corridor is part of the broader Eastern Piedmont Fault System reactivation that the Elgin sequence has been documenting since December 2021. The geological setting is a strike-slip fault network of late Paleozoic age running northeast to southwest through the South Carolina Midlands, with the Lake Murray Reservoir sitting on top of multiple known fault strands. The setting is the setting in which a Moodus-style mechanism, in which very shallow seismic events produce atmospheric pressure pulses through direct surface coupling, could in principle operate. The Moodus mechanism is the precedent that the seismo-atmospheric reading rests on. In Moodus, Connecticut, in the Salmon River Valley in the central part of the state, residents have reported booms and rumbles for centuries. The Native American populations of the area had a word for the booms that translates loosely as the place of noises. The European settlers of the 17th and 18th centuries reported the same booms and gave them the English name Moodus noises. The scientific investigation of the Moodus phenomenon began in earnest in the early 20th century and was substantially advanced by instrumental studies in the late 20th century, when seismic stations were deployed in the immediate vicinity of the area where the booms were reported. The instrumental studies established that the Moodus noises are, in many cases, associated with very shallow micro-earthquakes occurring at depths of less than a kilometre below the surface. The earthquakes are small, typically below magnitude 2, and would not normally be felt by people even at the surface directly above the epicentre. But the very shallow depth allows the seismic energy to couple efficiently into the atmosphere at the air-ground interface, producing a localised atmospheric pressure pulse that is heard as a boom by people within a few kilometres of the epicentre. The mechanism is well documented in the Moodus case. The seismo-atmospheric reading of the May 28th event extends the Moodus mechanism to a different geological setting and a much larger scale. The reading proposes that the Eastern Piedmont Fault system in the Lake Murray area is currently producing very shallow seismic events that are coupling into the atmosphere in a way analogous to the Moodus mechanism, and that the May 28th event was a particularly large expression of the same general process. Under the reading, the boom is a real atmospheric phenomenon driven by a real underground source, but the underground source is too shallow and too localized to register as a detectable earthquake on the standard scales, and the atmospheric expression of the source is what the instrumental network and the felt area community reports actually recorded. The reading has several pieces of evidentiary support. The spatial coincidence with the active swarm is the most direct. The geological setting is consistent with the mechanism. The Eastern Piedmont Fault system is producing the right kind of activity. The Talwani-Monticello reservoir-induced seismicity precedent provides a mechanism by which artificial reservoirs in the Piedmont can trigger sustained small event activity in the underlying fault network. The historical East Coast mystery boom literature is consistent with the general phenomenon of intraplate atmospheric coupling that the modern instrumental record is now beginning to characterize. The reading also has several pieces of evidentiary tension. The most important is the magnitude of the felt area. The Moodus mechanism produces a localized atmospheric perception of a boom, typically felt within a few kilometers of the very shallow epicenter, not a strong shaking footprint extending across 100 miles. The May 28th event produced a felt area more than an order of magnitude larger than any documented Moodus event in scale terms. The second piece of tension is the absence of any seismic component in the catalogue entry. The Moodus mechanism involves small but detectable seismic events that are recorded as small positive magnitudes in the catalogue, along with their atmospheric perception. The May 28th event was logged with no seismic component and an explicit 0.0 magnitude flag. Under a Moodus-style coupling, the seismic component should be present, even if small. The absence of the component is harder to explain under the reading, and the most plausible alternative explanation is that no seismic component existed because the source was not seismic. The third piece of tension is the geometry of the felt area. The Moodus mechanism produces a localized circular pattern centered on the very shallow epicenter with rapid attenuation outside the immediate vicinity. The May 28th event produced a circular pattern that is consistent with a point source, but the pattern extends across 100 miles, which is consistent with a point source at altitude rather than at the surface. The seismo-atmospheric reading is therefore in tension with the available evidence on multiple fronts. The reading explains the spatial coincidence with the swarm. The reading explains the geological backdrop. The reading does not cleanly explain the felt area magnitude. The reading does not cleanly explain the absence of a seismic component. The reading does not cleanly explain the geometry of the felt area at this scale. The reading is, at this stage, a plausible candidate explanation for some features of the May 28th event, but not for all of them. If the reading is correct, the predictions are clear. The Lake Murray corridor should continue to produce sonic boom-class events at intervals over the coming months and years, with the events correlating temporally with bursts of small earthquake activity in the same area. The events should have a characteristic point source geometry centered on the active fault zones. The events should be catalogued by the USGS in the same way the May 28th event was catalogued. And the catalogue over time should build a picture of a sustained phenomenon that the southeastern seismology community can study in detail. If the reading is incorrect, the predictions are different. The Lake Murray corridor will produce additional small earthquake activity, but will not produce additional sonic boom class events at any meaningful rate. The May 28th event will become an isolated data point in the catalogue, with no follow-on events of the same kind to build a pattern. The resolution of the reading depends on what the next several months produce. Part 11. Reading 2. Undisclosed military activity. The second main reading of the May 28th event is that the boom was produced by a military activity in the airspace over central South Carolina on Thursday afternoon, that the activity has not been publicly attributed to any specific operator or unit, that the absence of attribution reflects an institutional choice to manage the public-facing disclosure of the activity through channels other than a direct public statement, and that the catalogue entry and the limited agency responses together represent the federal government's chosen public-facing response to the event. The reading is the second of the two things the title of this video refers to, and it is the reading that has the most direct historical context, given the depth of military activity in the Lake Murray area and the surrounding central South Carolina region. The reading is supported by several pieces of evidence. The asymmetric agency response is the most direct. Shaw has formally denied responsibility. McIntyre has formally said nothing. The Federal Aviation Administration has neither attributed the event to a specific operator nor publicly addressed the absence of attribution. The pattern of selective response is consistent with a situation in which the federal government is choosing what to say and what not to say about the event. The reading is also supported by the structural fact that the catalogue entry exists at all. The USGS does not publish catalogue entries casually. The agency made a deliberate choice to log the event with the level of precision that the catalogue entry contains. The choice tells you that the agency wanted the public record to reflect what its instruments had recorded, regardless of whether the source of the event had been or would be publicly identified. The reading has several pieces of evidentiary tension as well. The geometry of the felt area is radial rather than linear. A single supersonic aircraft at altitude produces a linear felt corridor, not a radial pattern. The reading has to either propose a multi-aircraft coordinated operation, which is uncommon over civilian airspace and would normally require advanced FAA coordination that did not occur, or propose a single aircraft operation under unusual atmospheric conditions that amplified the ground response. The reading also has to explain the absence of any posted NOTAM for the relevant window. The standard pattern for military supersonic operations over civilian airspace is to file a NOTAM in advance so that civilian operators are aware of the activity. The absence of a posted NOTAM is consistent with either a continuous use special use airspace boundary, whose general authorization is publicly known and does not require event-specific notification, or with a violation of the standard notification process. If the reading is correct, the predictions are mixed. The disclosure window for the May 28th event will likely continue to close without a formal public attribution from any federal agency. The McIntyre silence will continue or will be broken by a carefully worded statement that does not directly address the substantive question of whether the base's aircraft were involved. The FAA will not retroactively post a NOTAM or attribute the event to any specific operator. The catalogue entry will remain in the public record as a permanent flag of what occurred without ever being followed by a public explanation. Over time, the event will join a small but non-trivial set of similar events in the southeastern United States and elsewhere whose source has never been officially identified. If the reading is incorrect, the predictions are different. A McIntyre statement will eventually emerge that confirms or denies the base's involvement. The FAA will eventually identify a specific operator or formally close the investigation as inconclusive. The catalogue entry will be supplemented by additional public-facing information that resolves the source attribution question. The two readings make different predictions about what the future record will look like. The two readings can, in principle, be distinguished by what the next several months produce. The two readings are not mutually exclusive in their weakest forms, but in their strong forms, the two readings make incompatible claims about the primary causal mechanism of the event. Part 12. The Frameworks. The Internet built in 12 hours. In the 12 hours following the publication of the USGS catalogue entry, online observers across multiple platforms generated additional frameworks for interpreting the May 28th event that go beyond the two main readings. The additional frameworks are not, in most cases, scientifically defensible, but they are part of the public conversation around the event, and the channel's editorial position is to engage them respectfully and to evaluate them against the available evidence. The first additional framework is the framework of covered-up military activity. The framework is the strong form of the undisclosed military reading, but with the additional claim that the cover-up is active and coordinated rather than passive and procedural. The strong form framework holds that the proximity of the event to Lake Murray, the historical use of Lake Murray as a primary World War II bombing range, the existence of nearby active military installations including McIntyre and the Poinsett Range, and the simultaneous official denials by shore, together suggest that an active military exercise or weapons test occurred over central South Carolina on the afternoon of May 28th, and is now being attributed to a sonic boom of unknown origin to avoid disclosing the activity. The strongest piece of supporting circumstantial evidence is the asymmetry of the response. Shore denied responsibility quickly. McIntyre did not. The FAA did not publicly resolve the question. The historical depth of military bombing operations in the immediate vicinity is well documented and was openly conducted from 1942 to 1945. Multiple B-25 bombers crashed into Lake Murray during that period under circumstances that were not fully disclosed at the time. The strongest piece of counter-evidence is that contemporary military exercises in the continental United States are governed by Federal Aviation Administration NOTAMs and by environmental and noise impact disclosures under the National Environmental Policy Act, and a coordinated cover-up of a daylight exercise large enough to produce a 100-mile felt footprint would require participation by multiple federal agencies across legal and disclosure obligations that are routinely audited. The energy budget of conventional military training ordnance, even the largest weapons in routine use, is well below what would be required to produce the recorded Community Intensity 6 footprint. The framework is internally coherent, but does not match the operational scale and disclosure mechanics of how the modern United States Department of Defense conducts continental United States activity. The second additional framework proposes that Lake Murray's selection as a World War II bombing range was not arbitrary, that the underlying geology of the lake bed makes the location attractive for continued experimental activity, and that the May 28th boom was the result of a current generation directed energy or kinetic energy test connected to programs being conducted in the broader Department of Defense research portfolio. The counter-evidence is substantial. The energy scales required to produce a felt atmospheric pressure event with a 100-mile footprint are very large. Directed energy weapons currently in any operational test status, including the most powerful ground-based and airborne high-energy laser systems, are orders of magnitude below the energy density required to produce the recorded pressure wave at the recorded standoff distances. The framework requires an unidentified weapon system of a capability not publicly known to exist, conducted in daylight over a populated area without environmental clearance, and recovered by an immediate cover-up. The narrative is logically possible, but compounds multiple low-probability assumptions to reach an outcome that simpler mechanisms can also produce. The third additional framework holds that the simultaneous presence of an active earthquake swarm at the location, the historical record of fault activity along the eastern Piedmont system, and the May 28th atmospheric pressure pulse are not coincidental, and that the official classification of the event as a sonic boom is an institutional choice to avoid acknowledging an unusual seismo-atmospheric coupling phenomenon at the location. Under the strong form framework, the agency is not saying nothing because it does not know. The agency is saying nothing because it knows something, and is choosing not to disclose what it knows. The counter-evidence is that the precision of the catalogue entry is what the agency normally produces for any catalogued event, that the absence of a follow-up explanation is consistent with the agency not having a follow-up explanation, rather than with the agency having one and withholding it, and that the agency's institutional culture of preserving the instrumental record while letting other agencies handle source attribution does not require any active suppression. The framework is closer to the legitimate scientific seismo-atmospheric reading than to the cover-up frameworks, but should not be elevated to a stronger institutional claim than the available evidence supports. The fourth additional framework has been advanced in real time by some independent online observers, holding that mystery booms along the East Coast follow a recurring pattern in which upper magnitude 5 or greater earthquakes on the West Coast are followed by acoustic events on the East Coast, and that the May 28th boom should be read as part of a continental scale pattern of plate motion that official geology has chosen not to acknowledge. The counter-evidence is that the proposed continental scale plate motion mechanism does not exist in the established geological literature. The North American plate is a single tectonic unit at the timescales relevant to the proposed mechanism, and stress propagation across continental scales on ours today's timescales does not match what is known about crustal mechanics. The proposed pattern of West Coast quake followed by East Coast boom has not been statistically established in any peer-reviewed catalogue analysis. The framework captures a legitimate frustration with institutional explanations, but does not identify a physically supported mechanism. The fifth additional framework holds that the May 28th event is one of many similar events that have occurred at military installations across the continental United States over the past 15 years, and that have been collectively attributed to various official explanations that range from sonic booms to meteors to industrial accidents to exploding seaweed, and that the pattern of attributions itself is the data, with the implication that the official explanations are part of a sustained effort to cover up an underlying reality that the federal government is not disclosing. The counter-evidence is that the historical pattern of unexplained events at military installations is, in fact, real, but the pattern is also consistent with the simpler explanation that the United States military operates extensively at military installations and that some of the operations produce consequences that the public-facing record at the time does not fully document, without requiring a sustained coordinated cover-up of a single underlying reality. The framework conflates a real institutional pattern of partial disclosure with a much stronger claim about a unified underlying cause that the available evidence does not support. Across all of the additional frameworks, the channel's editorial position is to take the framework seriously as expressions of public reaction to a genuinely unexplained event, to evaluate each framework against the available evidence, to acknowledge where the evidence partially supports a framework and where it does not, and to land on the position that the two main readings remain the two most defensible candidate explanations for the event. Part 13. The Seneca guns compared to this. It is worth spending a few minutes on the historical context of East Coast mystery booms, because the May 28th event is, in many ways, the first formally catalogued instance of a phenomenon that has been reported along the Atlantic seaboard for more than 2 centuries, and the historical context tells you something about both how rare the May 28th catalogue entry is and how broad the underlying phenomenon may be. The first documented references to East Coast mystery booms appear in early 19th century newspaper accounts from the coastal regions of the Carolinas and Virginia. The booms are described as deep, low-frequency rumbles that arrive without warning, that do not correspond to any visible source, and that occasionally produce a felt component in the form of shaking windows or rattled dishes. The name Seneca guns was first applied to the booms in the Finger Lakes region of New York in the early 19th century. The name was later extended to the booms reported along the Atlantic coast, and by the late 19th century the name Seneca guns was in general use for the broader category. The Moodus noises in central Connecticut are a separate regional name for the same general category of phenomenon. The United States Geological Survey maintains a public-facing reference page on East Coast mystery booms that summarizes the current scientific understanding of the phenomenon. The page acknowledges that the booms have been reported for 2 centuries, that the cause of most reported events has not been identified, and that while some events appear to be associated with very shallow earthquakes through the Moodus-style mechanism, the majority of events do not have a documented seismic correlate. The page is in effect the agency's formal acknowledgement that the phenomenon exists, that it is recurrent, that it has not been definitively explained, and that the current scientific tools are not adequate to fully characterize it. That acknowledgement matters for the May 28th event, because the May 28th event is the first event of the East Coast mystery boom category to be formally catalogued by the USGS with a precise event identifier, a precise time, a precise location, and a precise community intensity map. The historical Seneca guns were never catalogued at this level of detail. The historical Moodus noises were studied through dedicated instrumental campaigns, but were not entered into the National Earthquake Catalogue as formal events. The May 28th event is, in instrumental terms, the cleanest single record of the phenomenon that has ever been collected by a United States federal agency. That makes the May 28th event significant in a way that goes beyond the specific question of what produced it. The catalogue entry establishes a baseline for instrumental documentation of the East Coast mystery boom phenomenon that can be compared to future events as they occur. The next event in the corridor, if it comes, can be characterized against the May 28th baseline. The southeastern seismology community is, in effect, being handed a starting point for the systematic study of a phenomenon that has been unstudyable at this level of detail for 2 centuries. Part 14. What the catalogue is asking. Let us step back from the specifics of the May 28th event for a moment and ask what the catalogue entry itself, taken as a piece of institutional communication, is actually asking the public to do. Because the catalogue entry is not just a record, it is a request. The request is for additional information. The catalogue entry contains everything the USGS seismic network can contribute to the question of what produced the event. The entry contains a precise time, a precise location, a precise depth flag, a precise magnitude flag, a precise event type classification, and a precise felt area map. The entry does not contain a source attribution. The source attribution would have to come from elsewhere. It would have to come from the agencies that have access to the data needed to identify the source. The Federal Aviation Administration has access to aircraft tracking data. The Department of Defense has access to military operational records. NASA has access to satellite detection data. Each of these agencies has a different piece of the puzzle, and the catalogue entry is, in effect, a public-facing flag that the USGS contribution to the puzzle has been logged and that the other contributions are now needed. The request has not, as of the close of the briefing window for this video, been answered in full. NASA has contributed what it can, which is the absence of a meteor detection. Shore Air Force Base has contributed what it can, which is the absence of shore aircraft activity. The Federal Aviation Administration has not publicly contributed. McIntyre has not publicly contributed. The other relevant agencies have not publicly contributed. The catalogue entry stands as the public-facing flag, and the source attribution remains unfilled. The request is also for additional events of the same kind. The May 28th event is an isolated data point in the modern instrumental record. The phenomenon it represents, whatever the phenomenon turns out to be, is a phenomenon that can only be characterized through the accumulation of multiple data points over time. If the seismo-atmospheric reading is correct, additional events should occur in the Lake Murray corridor at intervals that the broader pattern of swarm activity would predict. If the undisclosed military reading is correct, additional events may occur in other military training environments at intervals that the broader pattern of operational activity would predict. Either way, the May 28th event is not the end of the data series. It is the beginning of one. The third thing the catalogue entry is asking is for the public to take the existing instrumental record seriously. The USGS could have, in principle, declined to publish the catalogue entry at all. The agency could have logged the signal in its internal archives without making the public-facing record available. The agency could have classified the event with less precision or with less institutional weight. The agency did none of those things. The agency published the entry with the same level of detail and precision that it uses for every notable seismic event in the catalogue. The agency took the event seriously enough to commit institutional resources to its documentation. The agency is, by the choice to publish the entry, asking the public to take the documentation seriously in turn. Part 15. The question the next boom will answer. We come then to the question that the May 28th event has formally placed in the public record, and to the question of what the next event in the catalogue, when it comes, will tell us. The question that the May 28th event has formally placed in the public record is this. The United States Geological Survey logged an atmospheric pressure event at 5:24 in the afternoon Eastern Daylight Time on Thursday, May 28, 2026, 6 kilometers north-northeast of St. Andrews, South Carolina. The event registered on the National Instrumental Seismic Network. The event was classified as a sonic boom in the structured event type taxonomy of the catalogue. The event was logged at 0 kilometers depth with a manual 0.0 magnitude flag. The event produced a felt area of more than 100 linear miles with a maximum community intensity of 6 on the modified Mercalli scale and a total of 1,454 community intensity map responses. The event is not an earthquake. The event is not a meteor. The event is not a Shore F-16, and no federal agency has, as of the close of the briefing window for this video, publicly identified what the event was. The question is what produced it. The two main candidate answers are the seismo-atmospheric coupling reading and the undisclosed military activity reading. The two readings make different predictions about what the next event in the catalogue will look like. The two readings can in principle be distinguished by the future record. The next event, when it comes, will be the first data point that begins to discriminate between them. If the next event is catalogued in the Lake Murray corridor with a similar 0.0 flag and a similar sonic boom classification, and if the event correlates temporally with a burst of small earthquake activity in the same area, the seismo-atmospheric reading will gain weight. If the next event is catalogued in a different part of the country with no spatial relationship to the Eastern Piedmont fault system, the seismo-atmospheric reading will lose weight, and the undisclosed military reading or some other reading will need to be considered. If no further event is catalogued at all for an extended period, the May 28th event will become an isolated data point that remains unexplained. The future record will, in time, tell us which reading is correct, or whether neither reading is correct and a third reading we have not yet identified is closer to the truth. The work of figuring out which reading is correct is not work that the channel can do alone. It is work that requires the continued instrumental monitoring of the southeastern United States by the USGS and the Southeastern Seismology Community, the continued operational records of the Federal Aviation Administration and the Department of Defense, the continued public-facing reporting of unexplained atmospheric events by witnesses across the country, and the continued integration of all of those data streams into a coherent picture that we do not yet have. What the channel can do is pay attention. What the channel can do is hold the catalogue entry up as the public-facing record of what occurred, walk through what the entry actually says and does not say, lay out the two main readings with the available evidence on each side, and stand ready to update the picture as new events occur. The next event is coming, in one form or another. If the seismo-atmospheric reading is correct, the next event will come in the form of another atmospheric pressure pulse in the Lake Murray corridor, and the catalogue entry for that event will look much like the catalogue entry for the May 28th event. If the undisclosed military reading is correct, the next event may come in the form of a McIntyre statement that fills in the picture, or it may come in the form of another unexplained event in another military training environment that the public-facing record does not fully address. If neither reading is correct, the next event will come in some form that we are not currently anticipating, and the picture will need to be revised to accommodate what the future record shows. But the next event will come. The May 28th event is the first instrumented record of its kind for this region. It is unlikely to be the last, and when the next one is logged in the catalogue, the work of building a picture of what these events actually are will continue, and the picture will become clearer over time. The signal coming off central South Carolina on Thursday afternoon was real. The catalogue entry preserves it. The question of what produced it is still open, and the planet, as it always does, is still talking. The work of decoding what it is saying is the work that will continue as the record builds, one entry at a time, in a catalogue that has, on this single afternoon, opened a new page for a phenomenon that has been waiting 2 centuries for somebody to listen carefully enough to begin to hear it.